this is like what you are going to work, but please realize that my equation is different from yours. So I have this height of a rock, h of x, in feet, and then x is in seconds. And right here, this little cool pointer thing, right here, I have my equation. I am going to find the average rate of change between these 2 points. How do I know this is average rate of change? Because it's 2 points. So I did all that gobbledygook stuff here. You can go through my algebra. You can check me to see if I got it right. And I get this value. Please remember what this value is. This is where you're just learning this, so you want to make notes. This is the slope of the secant line. And what if I wanted to know what the secant line is? Well, hey, I know how to do that. So what you like to do is visualize what this even means. So what we want to do is we want to go graph our function, and we want to plot these 2 points. Well, how do you get, remember points are x and y. Well, the first point I could plot would be where x is 1, and you know what y is? Where did I get that? Right there, that's h of 1. And then the next point would be 0.5 and 3.75. So it's important to know what you're doing and why we're doing this. So I'm going to try, if I can find it. Oh, I think it's right here. I am going to try to graph this stuff. So the very first thing I'm going to graph is my function. So you don't necessarily have to put h of x, but I did just for the sake of, I did. And then squared plus what, 9x. So it's kind of cool because I can visualize this rock being thrown up and then brought down. There are things you can do if you want, like you can say only make x greater than or equal to 0, but then you can see an issue here with the, I can see where it hits that line, or you can also put it between, and I'm doing less than or equal on the keyboard, but you can get those shortcuts down there, and I could do that. So this looks normal to me, right? This looks like, okay, the rock's being thrown up and being brought back down. Now remember, we had points. We had the point 1, 6, and I put a comma there, and then we had the point 0, 0.5, 3.75. The reason I like to graph, I want to make sure those points better be on that line, all right? Because if they were, you know, say you did something like this, and you're like, uh-oh, that's not even on my actual function, then you would know you made a mistake, okay? Always graph. Best advice ever given to me is graph it, graph it, graph it. Now I want to understand that line, okay? So you remember where that was right here. I got the y minus 6. So where did I get the 6? You can pick either point. I just happened to pick this point because I didn't want to deal with decimals, but you'll get the same line. So now I'm going to plot that line, which is y minus 6 equals, 4.5 and x minus 1. The other thing you should notice, this line better go through those 2 points. If it does not, then you made a mistake. Okay, this makes sense to me. I can see what's happening here. This is an ARC, an average rate of change between 0.5 seconds and 1 second. This 4.5 is the slope of this green line. But wait, there's more. Why are you in this class? Most of you already knew how to do this, right? So what we want to do now is we want to learn calculus. The horns go off. I want to know at an exact time. And so I'm going to look at exactly 1 second. So this is the formula that you're learning, this limit formula. So I put in what I want to know, plus remember that h, I call it the gap or some error. Some of you put 0.001, that is fine. I just leave it here because I'm not scared of algebra. And you can pause this and go through all my algebra steps to see if I made any mistakes. And then I get to my last step and I say let h approach 0 which means that is getting so small it basically disappears. So now what I got is, this is a slope again. This is the slope of the tangent line. And now I'm only looking at the 1 point, and then this is my tangent line. So probably should check myself, go back here, and let's type in the tangent line, y minus 6 equals 3 times x minus 1. And I better hope, I really hope that I am only touching at that point. And it looks like I did a good job, so the crowd goes wild, everybody cheering, woohoo! Looking good. But please graph this stuff so you can visualize. I want to know what the slope, and it's kind of funny, you know, we won't use the word slope all the time. I want to know how fast that rock is traveling at 1 second. Well, apparently it's traveling, and that's what these values, you have to remember this slope, it's traveling at 3 feet per second. Where this was between 0.5, half a second, and 1 second, it was traveling at this speed. So you can see what's happening, it's starting to slow down. All right, hope that helps with this activity.